March 6, 1944. Rechlin-Lärz Airfield, Mecklenburg, Germany. The cold morning air hung thick with aviation fuel and uncertainty as Hauptmann Werner Mölders supervised the unloading of a captured American fighter from a Wehrmacht transport railcar. The aircraft had been shot down 2 days earlier during the Americans' first major daylight raid on Berlin, and what the Luftwaffe's technical intelligence team would discover in the coming weeks would fundamentally shatter everything German high command believed about American capabilities and the future of the air war over the Reich. The P-51 Mustang, tail number 4-3-6827, arrived at Rechlin largely intact despite the violence of its crash landing near Brandenburg. Its pilot hadn't survived, but the airframe told a story that German engineers were desperate to understand. For 3 years, Luftwaffe intelligence had operated under a comforting assumption. No American single-engine fighter possessed sufficient range to escort bombers deep into Germany. Berlin, 560 miles from English bases, lay safely beyond the operational radius of any known Allied fighter. This wasn't speculation. This was verified by captured P-47 Thunderbolts and P-38 Lightnings, both of which demonstrated clear fuel limitations that forced them to turn back before reaching the German capital. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Yet on March 4th, and again on March 6th, something impossible had occurred. American single-engine fighters, sleek silver aircraft with distinctive bubble canopies, had escorted over 800 bombers all the way to Berlin, engaged Luftwaffe interceptors in sustained combat over the city, and somehow possessed enough fuel reserves to fly the 560 miles back to England. The implications were staggering, and Hauptmann Mölders, along with the entire technical staff at Rechlin, understood immediately that they were examining evidence of a profound strategic shift. Rechlin-Lärz served as the Reich's primary aircraft testing and evaluation facility, Germany's equivalent to America's Wright Field or Britain's Farnborough. Here, teams of engineers and test pilots systematically analyzed every captured Allied aircraft, searching for vulnerabilities, measuring performance characteristics, and attempting to understand the industrial and technological advantages their enemies possessed. The facility had examined dozens of Allied aircraft since 1939, from early Hurricanes to the latest Spitfire variants, but nothing prepared them for what they were about to discover about American industrial capacity. Major Adolf Galland, General der Jagdflieger and one of Germany's most successful fighter aces with over 100 confirmed victories, had personally encountered formations of these mysterious American fighters during combat missions over Berlin. Despite holding an administrative position, Galland flew combat whenever possible, unwilling to lead from behind a desk while his pilots faced death daily. His combat reports, submitted through official channels on March 8, noted details that contradicted everything Luftwaffe intelligence believed about Allied fighter capabilities. The American fighters operated at full combat power over Berlin, Galland wrote. They engaged aggressively with no apparent fuel conservation behavior. They maneuvered freely, fought confidently, and showed no signs of being at the absolute limits of their operational range. Most critically, they weren't simply reaching Berlin and immediately turning for home. They had reserves. Substantial reserves. Enough fuel to fight prolonged engagements lasting 15 to 20 minutes, then fly 560 miles back across hostile territory to their bases in England. This was impossible, according to every calculation Luftwaffe intelligence had performed. Yet Galland's observations, corroborated by reports from dozens of other German pilots, painted an undeniable picture. The Americans had solved the Escort fighter problem. The question that would haunt German planners for the remainder of the war was simply, how? The technical examination at Rechlin began with the fundamentals. German engineers measured the Mustang's internal fuel capacity with meticulous precision. They found 2 wing tanks, each holding 92 gallons of aviation fuel, for a total of 184 gallons in the wings. Additionally, the fuselage contained an 85-gallon fuel tank positioned directly behind the cockpit. This fuselage tank represented a relatively recent modification to the P-51B design, incorporated during production specifically to extend operational range. Total internal fuel capacity measured 269 gallons. The Packard-built Merlin engine, a licensed version of the legendary British Rolls-Royce Merlin that had transformed the Mustang from an adequate low-altitude fighter into a superb high-altitude interceptor, consumed fuel at varying rates depending on power settings. German engineers, working from captured technical manuals and their own performance testing, calculated that at economy cruise settings, the engine burned approximately 60 gallons per hour. At normal cruise power, consumption increased to approximately 75 gallons per hour. At combat power settings, consumption exceeded 100 gallons per hour. Using these figures, German analysts performed range calculations. With 269 gallons of internal fuel and consumption of approximately 70 gallons per hour at cruise settings, the P-51B could theoretically fly for roughly 3.8 hours. At the aircraft's cruising speed of approximately 300 miles per hour, this yielded a maximum range of 1,140 miles. This was precisely enough to reach Berlin from English bases and return, but only barely, with virtually no reserves for combat operations, warming up engines, or dealing with adverse weather. The mathematics simply didn't work. Combat reports clearly indicated American fighters engaged in prolonged dogfights over Berlin, sometimes lasting 15 to 20 minutes of high-intensity maneuvering before disengaging and flying home. Combat power settings, consuming over 100 gallons per hour, meant that even 15 minutes of combat would burn approximately 25 gallons of fuel. Such expenditure should have left the aircraft unable to complete the return journey. Multiple Mustangs should have been ditching in the North Sea or crash-landing in occupied territory, their fuel exhausted somewhere over Holland or Belgium. Yet American losses remained surprisingly low, and those losses that did occur appeared to result primarily from combat damage, not fuel starvation. The answer became apparent when technical staff examined the P-51's wing structure more carefully. The Mustang featured standardized hardpoints under each wing, designed specifically to accommodate external stores. These attachment points included fuel line connections, indicating they were engineered precisely for external fuel tanks. Drop tanks themselves weren't revolutionary technology. The Luftwaffe had employed them since the Battle of Britain. The Messerschmitt Bf-109 could carry a 300-litre drop tank. The Focke-Wulf FW-190 regularly employed them for extended-range missions in the East. Drop tanks allowed aircraft to carry additional fuel externally, then jettison the empty tanks before entering combat, reducing weight and drag to restore full combat performance. This was standard practice for all air forces by 1944. The question facing German intelligence wasn't whether the Americans were using drop tanks, that much was obvious. The critical questions were, what capacity did these tanks possess, and more importantly, how were the Americans producing enough of them to maintain such intensive operational tempo? If the Americans were mounting sustained operations with hundreds of fighters, each carrying drop tanks, the production requirements would be staggering. Metal drop tanks required aluminum, skilled metalworkers, specialized forming equipment, and significant manufacturing time per unit. Germany's own aluminum production was already strained to its limits by aircraft, vehicle, and munition production. If the Americans possessed enough aluminum to mass-produce large-capacity drop tanks while simultaneously building fighters, bombers, and everything else their war machine required, then American industrial capacity exceeded even the most pessimistic German estimates. The search for American drop tanks from the March missions began immediately. Intelligence officers plotted likely jettison points based on engagement locations reported by Luftwaffe pilots. Standard doctrine called for fighters to release drop tanks when encountering enemy aircraft, as external stores significantly reduced maneuverability and speed. Search teams composed of Wehrmacht personnel and Hitler Youth volunteers spread across the countryside northeast of Berlin, looking for any debris from the recent air battles. Within 3 days, several objects were recovered from fields and forests in the Brandenburg region. Most arrived at Rechlin in fragmentary condition, crushed on impact or damaged during the fall from altitude. But 2 examples reached the facility in relatively intact condition, having landed in soft agricultural soil or winter wheat fields that cushioned their impact. What German engineers discovered when they examined these recovered drop tanks would fundamentally alter their understanding of American industrial methods and strategic thinking. The captured drop tanks were cylindrical, measuring approximately 108 inches in length with a diameter of roughly 22 inches at the widest point. Initial capacity calculations indicated each tank held approximately 108 US gallons, equivalent to roughly 400 liters. Two such tanks would provide 216 additional gallons of fuel, extending the P-51's total fuel capacity from 269 gallons to 485 gallons. With this fuel load, the mathematics suddenly made perfect sense. A Mustang carrying 485 gallons could fly for approximately 6.7 hours at cruise power settings, yielding a range exceeding 2,000 miles. This was more than sufficient for the Berlin mission with substantial combat reserves. The fuel capacity mystery was solved. But what captured the immediate and shocked attention of German engineers was not the tank's capacity, but rather their construction. The drop tanks were not made of metal. Running a hand along the surface revealed a texture completely unlike aluminum or steel. The silver paint coating the exterior couldn't disguise the fundamental nature of the material beneath. When engineers carefully scraped away a small section of paint near the tail cone using a knife, they discovered multiple layers of heavy paper, each layer perhaps half a millimeter thick, compressed and laminated together with a resinous adhesive. Paper. The Americans were manufacturing fighter aircraft fuel tanks from paper. The construction proved sophisticated and purposeful upon closer examination. The nose cone and tail cone were formed from overlapping pieces of paper material pressed into shape using techniques similar to papier-mâché. Each individual piece was visible as a slight ridge where it overlapped with adjacent pieces, creating a subtle scalloped texture across the surface. The center section was seamless, wrapped around a cylindrical form in continuous layers without visible joints. The fuel fittings were brass, precisely machined and properly sealed with rubber gaskets. Peering through the filler cap revealed an interior coated with what appeared to be a cellulose-based lacquer, designed specifically to resist the corrosive effects of aviation gasoline. German materials specialists were immediately brought in to analyze the tank's construction in forensic detail. The paper was identified as kraft paper, manufactured using a chemical pulping process that produced exceptionally strong cellulose fibers. This was the same material used throughout industry for heavy-duty shipping containers and industrial packaging. Nothing exotic, nothing rare. The adhesive proved to be a resorcinol formaldehyde resin, a thermosetting polymer that created bonds stronger than the paper substrate itself when heat-cured. The lamination involved at least 12 separate layers of paper, each one carefully oriented to provide strength in multiple directions, similar to plywood construction. Anti-slosh baffles made from thin wood were installed inside to prevent fuel from surging during aggressive maneuvers. The entire construction process was clearly standardized and designed explicitly for mass production. Most significantly, the empty tank weighed approximately 80 pounds, compared to 65 to 75 pounds for a comparable metal tank of smaller capacity. The paper construction wasn't significantly lighter than metal, eliminating weight savings as the primary motivation. The tanks offered other advantages that German engineers immediately recognized as far more strategically significant than simple weight reduction. The implications crystallized with brutal clarity. The Americans were manufacturing fuel tanks from non-strategic materials. Paper and wood-based resins didn't require aluminum, steel, magnesium, or any of the metals that were increasingly scarce in all wartime economies, but particularly in Germany's shrinking industrial base. The manufacturing process required no specialized metalworking equipment, no skilled metal workers trained in forming and welding techniques, no expensive dies or presses for shaping sheet metal. These tanks could be produced in any paper mill or packaging factory, with relatively simple modifications to existing equipment. The United States possessed hundreds of such facilities. If even a small percentage of American paper production capacity had been converted to drop tank manufacturing, output could easily reach thousands of units per week. The tanks appeared to have no serial numbers, no manufacturer markings, nothing to indicate limited production runs or specialized manufacturing. They were commodity items, mass-produced and completely expendable. Single-use items manufactured at such low cost and in such quantity that losing them presented no logistical or economic burden whatsoever. Intelligence officers began researching American paper industry capacity, pulling pre-war trade publications and economic intelligence reports from archives. The United States produced approximately 12 million tons of paper annually before the war, with production increasing substantially during wartime mobilization to meet military requirements for maps, documents, technical manuals, packaging, and now, apparently, fighter aircraft fuel tanks. Converting even 1% of this massive production capacity to drop tank manufacturing would theoretically yield over 100,000 tanks per month, far exceeding any plausible operational requirement for P-51 operations. The real constraint wouldn't be raw materials or manufacturing capacity. America had effectively unlimited supplies of wood pulp, the base material for paper production. The constraint would be the availability of specialized assembly equipment and trained labor to construct the tanks according to precise specifications. But this was precisely the type of manufacturing that could be performed by semi-skilled workers after minimal training. No apprenticeships required, no years of experience forming metal, just workers following standardized procedures, laminating paper layers, forming them over molds, installing fittings, and applying protective coatings. The paper tanks represented industrial efficiency and resource optimization on a scale that German planners found genuinely difficult to comprehend. Further analysis revealed additional details about the design and operational use that demonstrated sophisticated engineering thinking. The tanks were strictly single-use items by design. The resorcinol adhesive, while creating extremely strong bonds when properly cured, was slowly dissolved by prolonged contact with aviation gasoline. Intelligence reports combined with interrogations of captured American aircrew indicated that paper tanks had to be filled immediately before flight and couldn't be stored filled for more than a few hours without developing leaks as the fuel gradually degraded the adhesive bonds. This wasn't a limitation that affected operational employment. Fighters were fueled as part of standard pre-flight preparation procedures. The tanks would be filled. The aircraft would fly its mission for a few hours. Then the tanks would be jettisoned over enemy territory. The single-use nature actually simplified logistics significantly. There was no need to recover and transport used tanks back to bases. No need for cleaning, inspection, or maintenance of returned tanks. No need for storage facilities or inventory management of reusable equipment. They were expendable by deliberate design choice, and that design choice revealed American strategic thinking. Build them cheap, build them in massive quantities, use them once, and build more. The German evaluation also noted the color-coding system employed by American ground crews. Paper drop tanks were painted silver, while metal tanks used by American forces were painted gray. This color distinction allowed ground crews to quickly identify tank types during rapid fueling operations, ensuring that paper tanks were used appropriately and not stored filled beyond their safe service life. The silver finish on paper tanks also helped reflect solar heat radiation, reducing fuel evaporation rates and vapor pressure issues at high altitude, where temperature variations were extreme. Every single aspect of the design reflected systematic engineering optimization for mass production, ease of field use, and operational efficiency. By late March 1944, German intelligence had traced the origin of paper drop tanks to British development efforts. The Air Ministry in London had commissioned development of impregnated paper fuel tanks in 1943 specifically to conserve strategic metals, particularly aluminum, which was needed for aircraft production. The Escort Corporation, utilizing extensive expertise in industrial paper manufacturing, developed the production process. The tanks entered service with RAF fighter squadrons in late 1943 for operations over occupied Europe. American forces quickly recognized the advantages and adopted the design, with multiple manufacturers in both Britain and the United States producing tanks for use by USAAF fighter groups throughout the European theater. The innovation had been driven initially by British resource scarcity, Britain's island economy struggling under submarine blockade, but the design was being exploited on a truly massive scale by American industrial capacity. This was the critical distinction that German analysts immediately grasped. The British developed paper tanks because they desperately needed to conserve aluminum for aircraft production. The Americans adopted paper tanks not because they lacked aluminum, but because paper tanks were cheaper, faster to produce, and freed aluminum for other uses, while providing identical operational capability. This was optimization by choice, not desperate substitution driven by scarcity. The broader implications extended far beyond fuel tanks. German technical staff at Rechlin initiated a systematic review of all captured American equipment in their possession, specifically looking for other examples of industrial innovation and mass production techniques that might reveal similar patterns. The results of this comprehensive analysis painted a remarkably consistent picture that senior Luftwaffe officers found deeply disturbing. American equipment was not always technologically superior to German equivalents in terms of individual component performance. German optical instruments, the famous Zeiss gun sights and rangefinders, were often demonstrably better. German small arms, the Mauser rifles and MG-42 machine guns, were often more sophisticated in mechanical design. German armor metallurgy was in certain specific respects more advanced, particularly in the hardening processes for tank armor. But American equipment was consistently better manufactured, more standardized, vastly more reliable, and available in quantities that exceeded German production by factors of 5, 10, sometimes 20 to 1. The American industrial approach prioritized producibility over perfection. Components were designed from the very beginning of the development process for mass production by semi-skilled workers using standardized tooling. Parts were genuinely interchangeable between units without hand-fitting or individual adjustment. Assembly line methods, pioneered by American automobile manufacturers and now applied to weapons production, dramatically reduced production time and exponentially increased output. A single factory could produce more in a month than an entire German industrial region could manage in the same period. The contrast with German production methods was stark and philosophically profound. German weapons and equipment were often genuine technical masterpieces, hand-fitted by skilled craftsmen who had served multi-year apprenticeships. A German tank or aircraft engine represented the absolute peak of precision engineering, individual tolerances measured in hundredths of millimeters. Surface finishes polished to near-mirror smoothness, every component optimized for maximum performance. But building such equipment required highly skilled labor, specialized precision tools, and significant time investment per individual unit. Production rates were fundamentally constrained by the availability of master craftsmen and precision manufacturing equipment, both of which took years to develop. The Germans built superior individual items through craftsmanship. The Americans built adequate items in overwhelming quantity through industrial engineering. In industrial warfare, where equipment was consumed, destroyed, and expended at staggering rates, quantity had proven strategically decisive. One perfect tank destroyed in combat provided no more military value than an adequate tank similarly destroyed. But if one side could field 10 adequate tanks for every perfect tank the enemy produced, the mathematical outcome was inevitable, regardless of individual quality. Analysis of P-51 Mustang production specifically illustrated this fundamental principle with brutal clarity. North American Aviation had designed the original Mustang prototype in response to a British requirement issued in April 1940. The prototype, designated NA-73X, was completed just 117 days after the contract was signed, representing one of the fastest design-to-prototype cycles in aviation history. The first flight occurred on October 26, 1940. By 1944, North American was producing P-51 variants at 2 major facilities operating around the clock. The Inglewood plant in California averaged approximately 364 Mustangs per month during peak production periods in mid-1944. The Dallas plant contributed substantial additional production. Combined output across both facilities reached an average of approximately 574 P-51s per month during 1944, with production rates accelerating throughout the year as manufacturing processes were refined and optimized. Peak monthly production would ultimately reach 881 aircraft in January 1945. Each P-51 required approximately 15,000 individual parts, manufactured by hundreds of subcontractors distributed across the United States. The Packard-built Merlin engines were produced in Detroit at rates exceeding 300 units per month. Final assembly of a P-51D required approximately 22,000 man-hours of labor when calculated across all suppliers and subcontractors. But the production line system meant that completed aircraft rolled out of the final assembly building at intervals of just a few hours. At peak efficiency, a new Mustang was completed approximately every 2 hours, 24 hours per day, 7 days per week. The scale and ruthless efficiency of this production system exceeded anything Germany had achieved or could realistically hope to achieve, given its current industrial situation. Messerschmitt and Focke-Wulf combined produced approximately 600 fighters per month in early 1944. Despite operating under emergency priority programs, utilizing forced labor from concentration camps and occupied territories, and receiving absolute priority for resources, German aircraft production simply could not match American output. The United States was producing nearly as many fighters in a single month as Germany produced in an entire quarter. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The resource implications proved equally sobering when German intelligence compiled comprehensive assessments. American aluminum production in 1944 reached approximately 1.2 to 5 million tons, equivalent to £2.5 billion annually. This represented a massive increase from pre-war production of approximately 164,000 tons in 1939. In just 5 years, American aluminum production had increased by nearly 800% through construction of massive new smelting facilities, powered by hydroelectric dams in the Pacific Northwest and Tennessee Valley. Germany's aluminum production, by direct contrast, peaked at approximately 250,000 tons per year and was actively declining throughout 1944 due to Allied strategic bombing of production facilities and the progressive loss of bauxite sources in occupied territories. The Americans possessed approximately 10 times Germany's aluminum production capacity. 10 times, and this disparity was widening as Allied bombing intensified and German production fell further. The decision to manufacture drop tanks from paper rather than aluminum was not driven by American metal scarcity. The stark reality that German analysts had to confront was that the United States possessed sufficient aluminum production to manufacture every single drop tank in metal if they desired. Paper was chosen deliberately because it was cheaper per unit, required less critical manufacturing equipment, freed aluminum for other priority uses like airframe construction, and could be produced more quickly with less skilled labor. This was optimization for efficiency, not desperate substitution driven by shortage. The psychological impact of these revelations spread rapidly through Luftwaffe technical and operational communities during the spring of 1944. The paper drop tank became a powerful symbol of American industrial capability and the fundamental, unbridgeable disparity in resources between the combatants. Captured examples were displayed prominently at technical briefings for Luftwaffe personnel transitioning to operational units. Pilots preparing for fighter duty were shown the tanks and instructed to calculate the tactical implications for combat operations. The message was deliberately clear and unavoidably grim. American fighters could now escort bombers anywhere in Germany with fuel to spare. The previous defensive strategy of waiting for Allied fighter escorts to reach their fuel limits and turn back for home was completely obsolete. Luftwaffe fighters would have to engage the escort fighters directly to reach the bomber formations, and those engagements would cost aircraft and trained pilots at rates Germany fundamentally could not sustain. Adolf Galland provided the formal operational assessment in multiple conferences with senior Luftwaffe leadership throughout the spring and summer of 1944. The P-51 was definitively superior to German fighters above 20,000 feet, he emphasized repeatedly in written reports and verbal briefings. It was faster than the Bf-109 at altitude and more maneuverable than the FW-190. With the extended range provided by drop tanks, it could escort bombers throughout their entire mission profile from takeoff to landing. German fighters could no longer attack bomber formations unopposed after Allied escorts turned back due to fuel constraints. Every single intercept now required fighting through a dense fighter screen of aircraft that held both performance and numerical advantages. Loss rates were climbing steadily and unsustainably. The statistical evidence supported Gallen's assessment with brutal mathematical precision. In January 1944, the Luftwaffe lost approximately 90 fighters in combat, while claiming approximately 150 Allied aircraft destroyed. The exchange ratio, while unfavorable, remained within theoretically sustainable limits. By February, German losses had increased sharply to approximately 160 aircraft against approximately 230 Allied losses claimed. The trend was unmistakably clear and completely unsustainable for Germany. The Americans and British were replacing their losses faster than Germany could inflict them, while German losses were accelerating faster than replacement aircraft and pilots could be produced and trained. The summer of 1944 brought the full catastrophic impact of American escort fighter capability. The 8th Air Force conducted deep penetration raids almost daily whenever weather conditions permitted operations. Mustangs provided continuous escort coverage from England to targets across Germany and back to base. Luftwaffe fighter losses mounted at rates that could only be described as catastrophic. In June 1944, approximately 350 fighters were lost, defending the Reich against Allied bombing raids. In July, losses exceeded 350 single-engine fighters in the Western Theater alone, representing a monthly attrition rate of 31.2%. August witnessed similar devastating losses with a 36% monthly attrition rate. At these loss rates, experienced pilots with hundreds of combat hours were being killed substantially faster than they could be replaced through the training pipeline. The replacement pilots arriving from training schools possessed perhaps 150 hours of total flight time, compared to 300 hours or substantially more for American replacement pilots. Many German replacement pilots had as little as 30 hours flying time in their assigned aircraft type before being thrust into operational squadrons facing combat. The experience gap, combined with numerical inferiority and the constant presence of P-51 escorts operating with apparent impunity, made daylight operations over Germany increasingly deadly for Luftwaffe personnel at all experience levels. Galland submitted repeated assessments to Hitler and senior Wehrmacht leadership throughout this catastrophic period. His September 1944 report stated the situation with absolute bluntness that risked severe consequences. The Luftwaffe could not win the air war over Germany. Germany fundamentally lacked the resources, the aviation fuel, the replacement aircraft, and the trained pilots necessary to effectively contest Allied air superiority. The Americans could replace their losses substantially faster than Germany could inflict them through combat operations. Their industrial capacity existed beyond Germany's ability to meaningfully counter through tactical or operational actions. The only potentially viable strategy remaining was to carefully husband dwindling resources for defense of absolutely critical targets and hope desperately for some form of political settlement before complete military collapse. The paper drop tanks continued falling across Germany throughout late 1944 and into 1945 as Allied air operations intensified. German civilians gradually learned to recognize the distinctive cylindrical shapes lying in agricultural fields and forests across the countryside. Initial incident reports sometimes described them as unexploded bombs or mines, causing localized panic until military authorities arrived and identified them as harmless spent fuel tanks. Detailed instructions were systematically distributed through civil defense organizations, explaining that the silver cylinders falling from Allied aircraft were empty fuel tanks, not weapons or incendiary devices. The psychological impact on civilian morale was carefully noted in security service reports compiled for senior Nazi leadership. The sight of massive enemy aircraft formation overhead in such overwhelming numbers that their contrails literally crisscrossed the sky casually discarding expendable fuel tanks manufactured from paper, powerfully reinforced the increasingly unavoidable message that the Allies possessed resources to literally waste, while Germany desperately scraped for every litre of aviation fuel and every kilogram of aluminum for weapons. Production. Technical intelligence staff continued systematically analysing captured American equipment throughout 1944, but the analytical focus gradually shifted from understanding current capabilities to documenting for the historical record the sheer scale of industrial disparity. Could Germany theoretically manufacture similar paper drop tanks? The technical answer was unambiguously yes. German chemical industry possessed the capability to produce suitable phenolic resins. German paper mills could manufacture kraft paper to required specifications. The basic manufacturing process wasn't particularly sophisticated from an engineering standpoint, but the practical answer remained definitively no. Germany's chemical industry was already operating at absolute maximum capacity, producing synthetic rubber to replace natural rubber supplies cut off by naval blockade, explosives for munitions, and numerous other critical materials for the war effort. Resin production for non-essential items like expendable fuel tanks simply could not be prioritized when every kilogram of chemical production was desperately needed elsewhere. The paper industry was fully committed to military requirements for maps, documents, technical manuals, and packaging materials. Most critically, there existed no meaningful operational requirement for extended-range drop tanks when the Luftwaffe's fundamental problem wasn't range but fuel availability. By late 1944, severe fuel shortages were grounding large portions of the Luftwaffe for extended periods. Pilot training programs had been reduced to absolutely minimal levels to conserve aviation fuel for combat operations. Operational sorties were fundamentally limited by fuel availability rather than aircraft availability. Multiple operational squadrons possessed serviceable aircraft sitting idle on airfields because no fuel existed to fly them. Building drop tanks to extend operational range was utterly meaningless when barely enough fuel existed for local defensive operations of short duration. The irony was stark and bitterly painful to German planners who understood the strategic situation. The Americans had comprehensively solved the fighter range problem with paper fuel tanks at precisely the historical moment when German fighters were being systematically grounded by fuel shortages resulting from successful Allied strategic bombing of synthetic fuel production facilities. Different problems, different industrial bases, fundamentally different outcomes. The Americans possessed more of literally everything: more aircraft, vastly more aviation fuel, more trained pilots, more aluminum, more total industrial capacity, and sufficient excess capacity to optimize engineering solutions like paper drop tanks that represented the difference between adequate and optimal rather than the difference between something and nothing. Germany was fighting a desperate war of scarcity against an enemy coalition for whom material scarcity simply was not a meaningful constraint on operations. By January 1945, the war's ultimate outcome existed beyond any reasonable doubt among informed German military personnel. Soviet forces were rapidly approaching the Oder River, less than 50 miles from Berlin. Western Allied forces had recovered from the temporary setback of the Ardennes offensive and were systematically pushing toward the Rhine River. The Luftwaffe could mount only sporadic, limited resistance, constrained primarily by fuel availability and the ongoing hemorrhage of experienced pilots. The systematic technical study of American equipment continued at Rechlin even as the strategic situation collapsed, but it had effectively become an academic exercise undertaken primarily for the historical record. The findings were carefully documented for potential post-war analysis, but they could no longer meaningfully influence the war's outcome. The final comprehensive technical analysis of the P-51 and its drop tank systems was meticulously prepared in late January 1945 as Soviet forces approached from the east. The report's conclusion was clinically unambiguous. The P-51 Mustang, equipped with expendable paper drop tanks manufactured from non-strategic materials, has rendered the German heartland functionally indefensible against American daylight strategic bombing operations. Germany lacks the industrial capacity to match American fighter production rates, the fuel reserves to sustain combat operations at required scales, and the trained pilots to replace losses at current attrition rates. The report was formally filed in Reich Air Ministry archives in late January 1945. Whether senior Nazi leadership actually read the assessment remains historically unknown. By that late stage of the war, technical reports analyzing American capabilities were simply confirming through detailed analysis what battlefield reality had already conclusively demonstrated. The Luftwaffe, which had dominated European skies with apparent invincibility in 1940 during the French campaign, was reduced to occasional desperate sorties by early 1945, desperately hoarding precious fuel reserves for missions that could not realistically change the fundamental strategic situation. American fighters roamed with complete freedom over Germany, systematically attacking targets of opportunity, escorting bomber formations, and establishing total air supremacy. Each paper drop tank falling from American aircraft overhead served as a tangible physical reminder of the industrial disparity that had ultimately decided the air war over Europe. The story preserved in technical reports, post-war interviews, and archival documents reveals the profound psychological impact on German technical personnel who examined these humble paper cylinders. They were not analyzing a superior weapon system in the traditional sense. The paper drop tank was not advanced technology. It was deliberately simplified design using non-critical materials specifically chosen for ease of mass production. But that very simplicity, that deliberate choice of paper over metal, carried a strategic message more devastating than any technical sophistication could have possibly conveyed. The Allies possessed such overwhelming industrial capacity that they could afford to optimize designs purely for mass production efficiency rather than maximum performance. They could manufacture fuel tanks from paper because they had effectively unlimited paper production, unlimited resin production, unlimited manufacturing capacity, and unlimited fuel to put in those tanks. The optimization was not driven by desperate scarcity as German substitute materials programs were, but rather by calculated efficiency, maximizing output while minimizing consumption of critical materials for other priority uses. Germany's most experienced engineers understood immediately and viscerally what this represented. They were not fighting an enemy that was desperately improvising with substitute materials as Germany itself was forced to do. They were fighting an enemy so extraordinarily wealthy in industrial resources that material substitution represented a deliberate choice made for marginal efficiency improvements, not a desperate necessity imposed by critical shortage. When German factories used wooden tail surfaces on fighters, it was because aluminum was desperately scarce. When American factories used paper drop tanks, it was because paper was slightly more efficient than aluminum for this specific application, while aluminum remained available in vast excess for other uses. Post-war interrogations of Luftwaffe personnel consistently returned to this fundamental theme when questioned about their wartime experiences. When asked to identify the specific moment when they first clearly understood that Germany would inevitably lose the war, many technical staff members and senior operational officers cited early spring 1944 as the definitive turning point. The arrival of long-range fighter escorts over Berlin marked a decisive, irreversible shift in the strategic balance. Hermann Göring, interrogated extensively after Germany's surrender, acknowledged that long-range American fighters had delivered a strategically decisive blow to German defensive planning and were among the most important factors in the ultimate outcome of the air war over Europe. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.